In this video we're going to review the control point dialog in LP360. We're going to use this to generate a accuracy assessment for our data set. I've already loaded in our control file, the LAS dataset file, and the raster file. First thing I'm going to do is turn off the display of the LAS data. One thing I've already done, I'm going to right click on the raster layer here, go to properties, and I've already disabled the enable linear percent clip. That way when I'm zooming in and out on my checkpoints down here, the display is not going to change depending on my zoom level. Kind of easier to identify the center of the checkpoints that way. So if you've flown with a low key PPK RTK system, or even if you use traditional control like this specific data set, we use traditional control to do our georeferencing, our corrections. It's a good idea to have checkpoints just to verify the accuracy of your data set. So that's what we're going to be doing right now. Make sure you have your control points toolbar on, and you're going to choose that shape file, your control point shape file. One thing to keep in mind, if your control points or checkpoint file is an ASCII format, you'll have to convert that into shapefile format. We have a video explaining that in the importing ASCII video, so just refer to that if you haven't done that yet. So let's click on our LP360 control points report dialog button up here. It's going to bring up this. By default, the quick set's going to be set to all. As long as you've labeled your control points using these designations, either FK for full check, FC for full control, and so on, you can quick set, guide yourself to those specific points. I've labeled all of my checkpoints as FK, so if I choose full check, it's going to drive me right to them. I've just got a few checkpoints for this project. I'm going to go ahead and zoom in and choose those specific FK points. Just zoom in a little bit more, and you don't want to click that dot is representing that checkpoint in relation to the point cloud and ortho that we've generated. So with the ortho, we are determining the horizontal accuracy or planimetric accuracy, and with the point cloud, which is still active, it's just not being displayed, we're going to be determining our vertical accuracy. So I'm just going to click and what looks like the center of the checkpoint, and then I'm just going to repeat for the rest of the checkpoints. So it's going to give me different statistics in the control points report. We're going to have mean error, the error range, root mean square error, and our ASPRS accuracy class. Got an XY planimetrics, a combination of X and Y, and then we have vertical. This vertical is pretty important. It's because it's going to tell us. It could tell us that we have some bias in the data. This is 0.07 feet, so it's really good. It's giving us our error range, so about 1/10 of a foot error range. That's pretty good as well. Rmse, and it's basically your ASPRS class times 3. That's going to give you your minimum contour interval. So we're saying, based on the accuracy that we're seeing in this data set, you can do as a small contour interval as 1/4 of a foot, which is really good. So, and it's going to be in the units that your project is in. So this project's in US survey feet. You can see down here. If this was in a different unit, then these numbers would represent meters or international feet, so on. So one thing we want to consider as well is our project settings, or what our shapefile is defined in as far as our coordinate reference system. Let's go ahead and export the report. Just going to have all these statistics that we were looking at. We're going to call it control report. Save. Let's go look at it. Okay, so you can see I've already have my horizontal defined as US survey feet, but I don't have my vertical defined. So what we can do, go to File here, go to Project Settings. I just clicked on this little radio button to the right of our project spatial reference system. Let's go ahead and define our vertical, so I know it's orthometric. GOA 12B US survey feet. Click OK. Click OK. I'm going to right click on that Ajax control, which is our control file. Set layer SRS using project SRS. Yes. Let's export this report again. We're just going to overwrite. Yes. Let's look at that again. Alright, so we can see both our US survey feet, so we got that designated. This is a text file, so you can go in and edit this however you want. So I could, if this was in meters, I could go in and say meters, but really the best way to do it is the way I showed you. Change those project settings, re-export, and assuming you've defined your shapefile properly, it's going to show the right units up here. Okay. So you can see what we've already looked at before, the X, Y, Z vertical. The planimetric, of course, is X and Y combined. And if you look down here, it's showing the checkpoints that we chose to run the accuracy assessment on, and it's showing those points we had turned off, which is going to be their full control. Up here we have the base station location. Obviously we don't use that either, so we have that turned off too. So just a great way to do an accuracy assessment, and also have a good polished report after you've run that as well.